All right, our new unit is going to feature some elements of working with circles and arcs, sectors of circles, lengths of arcs, segments of circles, and of course special angle relationships formed by radii, tangents, chords, etc. So it's going to be kind of an interesting amalgamation of awesomeness with working within the construct of a circle. There's going to be some familiar elements. There's going to be some twists and turns on the previously understood content. And we're going to focus on these first couple lessons just dealing with circumference and area, and then some extensions as we work through some special circumstances within circles. So our job is going to be to identify and name arcs. So we're going to learn a little bit of notation. Think of what we did back in Unit 1 when we labeled angles and labeled segments. There's going to be some new notation here in this lesson. We're going to find the measures of arcs and also the lengths for arcs. All right, and so that's going to be our goals today. But in order to do that, we need to know our basics about circles. And these are things that you're already quite familiar with, that a circle is a set of points that are equidistant from the center. We would call this circle P. And so we would draw a circle with a dot and then the capital letter P, because the circle has a center at point P. A radius is a segment whose endpoints are the center and a point on the circle. So segment PC or CP is a radius. PA or AP, PB or BP are all radii. They are all radii. A diameter is the segment that contains the center, but has the endpoints on the circle. So in this particular case, diameter AB has point P in between points A and B. Point A is on the circle, point B is on the circle. And then there's this last concept, which is not new to this unit. Just like some of these other concepts are not necessarily new here, we're just having the notation. A central angle is an angle whose vertex is at the center of the circle. Just like we discussed back in Unit 7, when we discussed regular polygons, and the central angles in regular polygons were the angles at the center of a circle in which the regular polygon was inscribed. And so a central angle would be like, for example, this one right here, or this one there, or then this straight angle that we would have in the picture. And so the way that we would name those, again, would be using three letters. We can't call them angle P because they all have that vertex at the center, at point P. So we can call it angle APC or CPA. We can call it angle BPC or CPB. And then we also have the straight angle, which could be angle APB or BPA for that matter. And so again, that notation of how we name angles, how we name segments, is going to help us in our thinking as we name arcs and find the measures of arcs in this lesson. All right, so the way that we find the measure of an arc is we need to know the measure of its central angle. So what we mean by that, the measure of a central angle is equal to the measure of the intercepted arc. We call that an intercepted arc because the radius, or the radii that make our central angle, intercept a part of the circle that has the same measure as this central angle. All right, so we are going to measure arcs using degrees. Seems a little bit strange. I don't want you to confuse the measure of an arc with the length of an arc. And that's going to be just a slight nuance there. We're used to measuring angles using degrees, but then measuring segments using length, using inches, meters, miles. And so here, this is going to be a little bit of both when we're talking about arcs. Arcs can have a measure in degrees, or radians, but that's another unit of measure that you'll learn about later. And it will also have a length in terms of like inches or feet or whatever. And so if this angle's measure is 30 degrees, then this arc's measure is also 30 degrees. If this arc's measure is 150 degrees, then this central angle's measure is also 150 degrees. All right? So hopefully nothing too crazy there. The measure of this straight angle is the measure of this semicircle, 180 degrees, or half of the whole 360. Along the way, just like when we would add angles measures back in Unit 1, we can also add arc measures. The arc addition postulate states that the measure of this arc from point A through point B all the way to point C is the measure of these parts, all right? The measure of arc AB and the measure of arc BC. One thing that you're going to notice is I have 3 letters here for the measure of arc ABC, and that's because this arc is bigger than or equal to, greater than or equal to 180 degrees. It's more than a semicircle. And so that means that we have to use 3 letters to name that arc. We'll talk about that in just a second. But it makes sense, just like when we went back to this example, that if I've got 30 degrees and 150 degrees for these arcs, that together they make 180 degrees for the measure of arc ACB. All right? So that arc addition postulate holds here. Here is a little bit about measuring arcs, identifying arcs, naming arcs. There's a lot of information here. Excuse the font there, it kind of put a little pointy hat instead of a curved arc over those letters. But here you'll kind of see we have 2 diameters drawn, AE and CD. So there's a lot of like just detail here that we want to make sure that we are understanding and comprehending. So the first thing is to notice that like AC and CE and ED and DA, these are all minor arcs. Minor arcs. That means that their measures are each less than 180 degrees. All right? If we know that these are diameters, then from D past A all the way to C, this is a semicircle. And so we would have to use 3 letters for it. To go from point D to point C, passing through point A, we need to be clear about which semicircle we're referring to. DAC is different from DEC. They are both having the same measure of 180 degrees, but they're both referring to different arcs. And so we're going to name them in different ways. All right? A major arc also requires that we use 3 letters. All right? And that's an arc that goes from A to C, but not the shortest way. If I say arc AC, I'm talking about this arc here. But if I'm talking about arc ADC, then I'm referring to this other part of the whole 360 around. All right? I could name this ADC, or I could name it AEC, but I will never use all 4 letters. There may be multiple ways to name the same arc. We've got to be okay with that. And just to make sure, just like there's multiple ways that we can name angles, sometimes there's multiple ways that we can name arcs. We just have to be cognizant of it, aware of it, and make sure that we're kind of just speaking the same language, even if we have different names for the same thing. All right, now here comes like the actual work type examples that we're going to get to here. I'm going to have you do a couple of these. I'm going to do a couple, but just trying to make sure that we can connect the concept of the central angle measure to the arc measure, or the arc measure back to the central angle, making sure that we understand angle addition as it relates to arc addition. They're the same concept. And so here, when I'm talking about the measure of this arc, we use this notation for the measure of arc BC. All right, just like when we're talking about the measure of an angle in degrees, we put the little m in front of that angle name. The measure of arc BC is going to be the same as the measure of the central angle BOC, which in this case, the measure of angle BOC is 32 degrees. The measure of arc BD, if I know now that this is 32 degrees, and I know that that CD is 58 degrees, then the measure of arc BD is going to be the measure of arc BC. We draw the 2 letters with a little arc above. The measure of arc CD. And we actually add those numbers together. 32 plus 58 makes 90. And so the measure of that arc, BD, I can use 2 letters there. I'm not going to use 3. I'm going to use just 2 letters because this number is less than 180. Right? Arc BD is 90 degrees. Arc ABC is all the way around. This appears to be a diameter, so we're going to go ahead and say that this is 180 degrees. The measure of arc AB, I'm not given the measure of this arc, I'm not given the measure of this angle, but we can solve that in a couple different ways. We can do some problem solving. We can take 180, the measure of this straight angle, minus 32, the measure of this central angle, and that would leave us with the measure of angle AOB, which then in turn would be the measure of arc AB. Or we could take the semicircle, 180, and subtract the measure of arc BC, to find the measure of arc AB. So there's a couple different ways that we can do that, but essentially what we're going to do in the arithmetic process is we are going to subtract 32 from 180 to get 148 degrees. All right. There are obviously a couple ways in which we can articulate how we do that subtraction and why we do that subtraction. And so the reasons why we do that, again, are to either say we're taking the straight angle minus this central angle to be left with this central angle, whose measure is the same as this intercepted arc. Or we can take the semicircle, which is 180, and subtract off this part, arc BC, which would leave us with arc AB. All right, you go ahead and find the measures of these other parts. That's expected in your notes. All right, we know these concepts from our previous courses and from previous work in this course. The circumference of a circle is found by taking pi times the diameter, or 2 times pi times the radius, since a radius, 2 radii is equal to a diameter. All right, and so we are going to use this as we find the lengths of arcs. So arc length, as a concept, is simply saying how far in distance is it from point A to point B walking along the circle. Not the shortest distance between those points, not the length of the segment AB, but what is the length of arc AB. And the length of that arc is essentially a fraction of the whole circumference. It's a percentage of the whole way around. So that percentage is going to be based on the measure of the arc, all right, which in turn is related to the measure of this central angle. So if I know the measure of this arc or the measure of this angle, then I can take it as a percent, as a fraction of the whole 360. The measure of this arc divided by 360 the whole way around, multiplied by the total circumference, would give us a fraction of that circumference. It would give us this fraction of that circumference. We can find this length in terms of pi in most cases, is how we will answer that. Right? We will answer in terms of pi. Okay? And so in this case, we have these two pictures. Go ahead and draw those as best you can. And we are given here a diameter of 16. On this one, we're given a radius of 15. We know that the measure of arc XPY is 240, but we need to find its length. We are given that we're given that the measure of arc XY is 90. They actually didn't tell us that, but we know that when we have perpendicular segments, they make right angles. So these radii are perpendicular, which means that this angle is 90 degrees, which means that this measure is 90 degrees. The length of arc XY is going to be this fraction of the whole circumference of a circle with diameter 16. So the way that we would articulate that is we would say the measure of the arc divided by 360 multiplied by the circumference. The measure of arc XY divided by 360 multiplied by the circumference. All right, in this case, it's pi times the diameter 16. The measure of the arc is 90. So we would have this total, pi times our diameter. And what that means is we can substitute these values. We know the measure of the arc. We know the length of the diameter. And when we multiply that, we get 1/4 of 16 pi, which is 4 pi. And again, we put our units there in inches. So this is 4 pi inches. Sometimes we will try to approximate that value, but for the most part, since we're trying to segue into Algebra 2 nicely, we will probably just work in terms of pi. Your job is to answer that second one. Okay, so that gives us our unit here, or the beginning of our unit, where our goal was to make sure that we could name arcs, identify arcs, find the measures of arcs, and then find the lengths of arcs as a percentage of the circumference. Please email with any questions or make any questions in your notes.